Okay, today we're going to talk about section F of chapter 2. This is dealing with numbers and regions. So basically, we're getting our Venn diagram, and this little piece here, I hope this is all readable from the video, but we're talking about the little areas in here where intersection points. So right here is where A and B intersect. And this comes about from the sketches you're doing. Everything on the outside, out here, is where the complement of A and the complement of B intersect. Okay? So that means if this is circle A and this is circle B, this piece is where A intersects with the complement of B. In the same way over here, this is where B intersects with the complement of A. So we use this kind of piece to answer questions using numbers. So this example 10, it says in the Venn diagram given, 5 means that there are 5 elements in the set A intersecting with B. How many elements are there in? So this is all about the numbers. I'm going to get rid of that part. So we get first question, how many elements are in the set A? Well, you get to take the whole circle. So everything in that circle is an element of A. So 12 plus 5 gives me 17. And then the next one says, how many elements are in the set complement of B? Well, whatever is not in B, those two are in B, so it has to be 12 plus 6. So 18 elements. So there's 17 elements and 18 elements. And then it wants to know how many are in A and B combined. So A union B. 12 plus 8 plus 5. So there's 25 in A union B. Because I'm taking all the elements within A and B. Then we have the number of elements in A, but not in B. So these are in B. Although those 5 are in A, they're in B. So we can only count the 12. Because I want what's in A not included in B. B, but not A. Well, it's the opposite. The 12 and 5 are in A, 8. And then the number of elements in the universal set that are in neither A nor B, 6. I'm hoping this is fairly visual, fairly straightforward, but we'll do another example. We're going to do example 11. I'm going to get rid of this so we can draw it. Make use of the top space here. And given universal number of elements in the universal set is 25. Number of elements in P is 10. Number of elements in Q is 12. The number of elements in P intersect Q is 3. So what we do is we want to find A, the number of elements in P union Q, and B, number of elements in P, but not Q. So, first thing you do is you're going to draw your Venn diagram. We got a circle, another circle, a really bad marker running out on me, so I'm going to grab a new one. And I got P, Q, universal. So, first thing we need to do is you always start with the intersection part. So why am I going to do this? Because we get it. If I look at the number of elements in P, and I were to say there's 10, but it means there's 10 in this whole circle. So I start with the intersection point, 3. Now, if there's 10 members of P, I take away the 3, and I get 7. 7 plus 3 makes that 10. The same concept is used on this side for Q. And that means I have 10 in P, that doesn't really matter, but I get 3 in the intersection, but there's a total of 12. So this has to be 9, because I take the 3 away from the 12 to give me the 9. Now, next thing, are we done? No, because we got to figure out how many are not in P or Q. That would be the complement of P and the complement of Q. So I've got 9 plus 3, I get my 12, plus 7. That's 19. That leaves me with 6. Now, the interesting part with this, if I were to look at just this, I would go, okay, there's 10 in P, 12 in Q. That only gives me 22. Or I'd go, well, there's 10 in P, 12 in Q, and 3 in P and Q, so that gives me 25, and that doesn't give me any left over. But we can't count that twice. So I've got 9 plus 3, 12, 19, that leaves 6 on the outside. Okay, so I pretty much have answered our questions. P union Q, everything in P and Q, so I count what's in the circles, and we got 19. And the number of elements in P, but not in Q, 7. Do I need the diagram? Probably not. You guys are probably all smart enough to go, well, there's 3 that are in P, but they're also in Q, so I take those away and I get my 7. And that's it for section F.